Okay, so for question 3, first part is to determine how many elements are in R. So remember, this is how we denote the cardinality of R. So I could also say this is absolute value of R. So if I write it in either way, I'm asking for the same thing. How many elements are in the set R? Now, what you need to remember about omega, that is that this is my universal set. So that is where I get all my elements. I do not have any other elements in this question apart from those that are in omega. Now, omega contains the numbers from 1 to 19, the natural numbers. So if I were to list them, it'll be 1, 2, 3, 4, 5, and then I stop at 19. Okay. P over here. So when you have a set represented in set builder notation, try and understand what it is saying, or try and say your rule in words, not necessarily mathematical way, like x squared is less than or equal to 50. What does that mean? Okay, so here it says that P contains natural numbers, and these natural numbers, if I square them, the answer is less than or equal to 50. So remember the elements over here, we can write them. We say this is 1, 2, remember your set braces, 3, and so on until 19, because we want them to be less than or equal to 20. Okay, so here we said we want natural numbers so that when I square them, not take natural numbers and then square them. I want natural numbers, not x squared. I want the natural numbers so that when I square them, the answer is less than or equal to 50. So I start with the first one, 1. When I square it, my answer is 1. So 1 is less than 50, so 1 is included. 2, when I square it, the answer is 4. 4 is less than or equal to 50. 3, 4, 5, 6, and 7. All those satisfy that. So here, I'll say P, this is equal to 1, 2, 3, 4, 5, 6, 7. Now, if I wanted to move on to 8, I would see that 8 squared is 64. It no longer satisfies this. So P is just the natural numbers from 1 to 7. Okay, and Q, try and say this in words. Q, these are the natural numbers. And what type of natural numbers? The natural numbers that when I multiply them by 2, my answer is greater than or equal to 7. So I want natural numbers that when I multiply them by 2, the answer should be bigger than or equal to 7. So I start with 1 multiplied by 2 is 2, not satisfying this. 2 times 2 is 4, not satisfying this. 3 times 2, not satisfying this. But 4 onwards, 4, 5, 6, and so on till 19 satisfy that. So these are my elements in roster form, my sets in roster form. So R, P, and Q. Now we start with the first one, the cardinality of A. So you write it in either of those ways. Remember, cardinality is a number. If I ask you how many elements are in a set, you're not going to give me an answer as a set. You'll say 5, 10, 0, and so on. So you'll give me a number. The cardinality of a set is a number. So here, if I look at this elements 2, 4, 6, 8, and I need to remember that I'm picking the elements from omega. So I only have the option of picking the numbers from 1 to 19. And these numbers here, you can see these are even numbers. So I want even numbers that are less than 19. So if I were to list these up until the end, I will have 2, 4, 6, 8, and I will continue up until 18. And you'll see that you'll have 9 elements. So that is why the cardinality of R is equal to 9. Then B, P intersect Q. Now P intersect Q is just looking for elements that are here and also over there. So 1 is here, but it's not there. 2, no. But 4, 5, 6, and 7 are. So the intersection of a set is a set. Okay, so this is 4, 5, 6, and 7. These are the elements in both P and Q. That is what intersection means, inside both of them. Okay, then C, P union R complement intersect Q. Okay, so this is like a multi-layered question, if you will. So you have to work out the union first, find the complement, and then intersect that with Q. So you can start with P union R. Union, remember, is elements that are in both sets, and the union of a set of two sets is also a set, so my elements must be in set braces. So P union R, so this is P, and when I combine it with R, you'll see that this is the numbers from 1 to 7, and then I combine all the even numbers in inside omega. So I'll have 1, 2, 3, 4, 5, 6, 7. So I take all the elements of P and then I combine them with the elements of R. So R has even numbers 8, 10, 12, 14, 16, and 18. Okay, so that is the union. Now I want the complement. Complement means those that are in the universal set but are not listed over here. So P union R complement. So 1 is here, so I don't put it. 2, 3, 4, 5, 6, 7, 8. I'm not going to list any of those. 9 is in the universal set but is not here, so 9. Then I have 11. Then I have 13. 14 is there. 15 is not. 16 is there, so I don't put it there. Then I have 17 and 19. Now these are the elements that are in my universal set but are not inside P union R. That is what complement means. It means you have your universal set. This is your universal set. And then you have another set over there. So I want elements that are over here. Okay, so they are inside the universal set. So you see the circle that represents the universal set. They are inside there, but they are not in here. Okay, so we continue. P union R complement, then I have to intersect it with Q. So I look for all the elements that are here as well as in Q that we worked out earlier. So the elements that are there, 4 you can see is only in Q, 5, 6, 7. So the intersection of this set and that one, P union R complement intersect Q, this is just equal to 9, 11, 13, 15, 17, and 19. So it is just equal to that.